Okay, we will speak about respiration. So the function of respiration is to saturate the cells and tissues with oxygen and to eliminate carbon dioxide. Oxygen is important because it oxidizes the organic molecules and releases energy. So cells consume oxygen and release energy and byproduct carbon dioxide. It should be eliminated, and this oxygen's delivery and elimination of carbon dioxide are the functions, the major functions of respiration. So in respiration consists of several stages, of several um, components. The first is so-called external respiration. External respiration, it is the exchange of air between lungs and environment. Exchange of air between lungs and environment is external respiration. Second is the gas exchange, the gases exchange in lungs between the alveoli and the blood. Exchange between alveoli and blood. Third stage is gas transport. Gas transport of carbon dioxide and transport of oxygen, transport with blood. And the last stage is tissue respiration. Biochemistry will give this information in details. We will speak about the first three stages of respiration. We begin with external respiration. The mechanism of inspiration, biomechanic of inspiration is the first question. Mechanism or biomechanic of inspiration. So the inspiration begins with contraction of inspiratory muscles. Contraction of special muscles. What muscles are should be mentioned in this question? It is external intercostal muscles. External intercostal muscles. Diaphragm, very important muscle for inspiration, and some other muscles. So what happens? These muscles enlarge the thorax. So enlargement of thorax. When external intercostal muscles contract, ribs elevate. So these muscles, external intercostal muscles, they increase the volume of thorax. And also diaphragm. When diaphragm contracts, it flattens. And it also increases the volume of thorax. Okay. The third stage of inspiration is due to the enlargement of thorax, the pressure in the pleural cavity. Decreases. So actually this pressure is always negative. The pleural cavity is the cavity between the lungs and the internal side of thorax. This is a thin space filled with the liquid to decrease the friction, and the pressure in this cavity is always negative. So it slightly different, and it is less, about minus 7 centimeters of the water column, centimeters of the water column during inspiration. So during inspiration it is less, during expiration it increases up to minus 3 centimeters of the water column expiration. So this negative pressure in the pleural cavity is crucial, is very important for respiration, because it expands the lungs. So if the pressure in the pleural cavity will become equal to the pressure in the atmosphere, the lung will collapse. The lung will collapse. So lung will collapse. So the lung is keeping its shape due to the negative pressure in the pleural cavity. Why lung collapses? Due to the elastic power. What are the components of this elastic power? So the first component of this strength of this mechanism is the surface tension. Surface tension of the water layer covering the alveoli inside. So the surface tension. Surface tension. It explains 2/3 of this power, and 1/3 of this elastic power of the lungs may be explained by the elastic fibers inside the lung. Elastic fibers inside the lungs. So let's go back. So the pleural pressure in the pleural cavity decreases, and for the lung expand. The lungs expand. Lungs expand. Lungs expand. P multiply V is constant. Constant. That's why when the volume increases, the pressure decreases. So the fifth stage is the pressure inside the lung decreases, and therefore air passively goes into the lungs. So air fills the lungs. So that's how it happens, the inspiration. Okay. Now let's go to expiration. What you should know about expiration. Expiration may be passive due to the gravity and due to the elastic fibers in the lungs, and may be active. Active expiration is explained by the contraction of expiratory musculature, by expiratory muscles like internal intercostal muscles. So for expiration, internal intercostal muscles, and muscles of the stomach, musculus rectus abdominis, musculus obliquus abdominis, etc. Stomach muscles. Okay. Now let's speak about the methods which may measure the lung volumes. These methods are called spirometry and spirography. Spirometry and spirography. So the difference is that spirometry simply measures, and spirography may present these volumes via a special graph. So the volumes, lung volumes. Let's draw the spirogram. When person is sitting or standing and in the quiet state, during each inspiration, about 0.5 liter of air goes inside the lungs. This volume, this lung volume, is called tidal volume, like tide in the ocean. Tidal volume. Tidal volume. So circa 500 ml going in and out during each respiration. After the quiet inspiration, the person may additionally inspire about 2.5 liters of air. This volume is called inspiratory reserve volume. Inspiratory reserve volume. About 2.5 liter. After quiet expiration, person may additionally expire about 1.5 liter of air. The sum of these volumes, inspiratory reserve volume, tidal volume, and expiratory reserve volume, will be about 4.5 liters, and it is called vital capacity. But even after the deepest expiration, about 1.2 liters of air is remaining in lung. It cannot be expired. This is called this volume called residual volume. Okay, there is also anatomical dead space. Anatomical dead space is the volume that is filling the air passages. The trachea, the principal bronchus, it's about 150 ml. And this air is excluded from the air exchange. That's why it is called dead space, the anatomical dead space. Okay, there are also so-called forced vital capacity, and forced vital capacity is the air that can be expired maximally during the forced expiration. It is about 150 ml less than the vital capacity. The crucial parameter is the TIFNO test. TIFNO test is measured as a ratio between the expiration volume per first second of expiration, forced expiration, and the forced vital capacity. Forced expiration volume during the first second divided by forced vital capacity. It should be more or equal to 0.8. If it will be less than 0.8, it will indicate that there are obstructive lung syndrome. Obstructive lung syndrome may be observed during, for example, bronchial asthma, when air passages are narrowed by the allergic processes, for example. In this case, special additional test may be provided by pharmaceutical agents that will stimulate beta-2 adrenoreceptors. If the inhalation of such pharmaceutical agents will be done to the patient, beta-2 receptors will induce the relaxation of the musculature, smooth muscles in the bronchial passages, and the TIFNO index will increase. It will be the good indication that there is a really obstructive lung syndrome in this patient. Okay, and let's speak also about the second stage of respiration. The second stage of respiration, as we already mentioned, is the exchange of air between the lung, between the alveoli and the blood, between the alveoli and the blood. So here we should speak about the partial pressure of gases in the alveoli and in the blood. Let's draw the alveoli. Let's draw the blood vessel. Here we have venous blood, and on the right side arterial blood. So the partial pressure of oxygen in alveoli is 100 millimeters mercury. 100 millimeters mercury. Partial pressure of carbon dioxide is 40 millimeters mercury. In the blood, the tension of oxygen, it is equal to the partial pressure, is 40 millimeters mercury. Partial pressure of carbon dioxide is 46 millimeters mercury. So we have simple diffusion. What happens? Oxygen goes to the bloodstream, carbon dioxide is released through the aerogematic barrier. It's very simple, it diffuses very quickly. And in the arterial part of the blood vessel, we have partial pressure of oxygen 100 and partial pressure of carbon dioxide is 40. It decreases in comparison with the venous part of the system. So what we have oxygenated blood, which is enriched with oxygen and which releases some amount of carbon dioxide. It was the second stage of the respiration. So in the next part we will speak about the gas transport with the blood and about the regulation of respiration. It will be in the respiration part 2.